Okay, done doing my homework. Took about 2 hours. Here's what we got. This is how you wire up a phase switch. Basically, you use a double pole, double throw. Yeah, look it up. Okay, so here's how you wire your coil split humbucker. Once again, you're using a double pole, double throw. And yeah, it's a little bit more complicated. This is how you wire up your series parallel switch for a humbucker. And once again, it's a double pole, double throw. And yeah, you can look it up. Look it up. That's what I did. Okay, so these are basically like for the 6 voices that you've got, where the plus and minuses ended up being connected for the various coils. For the A coil and the B coil, the plus and the minus wires. So for voice 1, the positive side of the A coil is going to go to positive, and the negative side of the A coil goes negative, and the B coil is not applicable because, come on, focus, because voice 1 is the A coil split, and voice 2 is the B coil split, and so yeah, positive and negative for the B coils, and nothing for the A's, and so on and so forth. So then I was thinking, okay, well, we need to turn coil A on and off and B on and off, and we need to be able to flip the phase of one of them, and then you need to switch it between series and parallel, and that's pretty much what you got to do. 2 coils, 2 on-off switches for the 2 coils, flip the phase on one, send it through a series parallel switch, and it's a done deal. So this is what the individual circuits for the 6 voices look like. That's for an A coil split, that's for a B coil split, that's for your humbucker in series, your standard humbucker, your humbucker coils in parallel for that jangly twangy thing. Oh no, sorry, that's just humbuckers in parallel. That gets you your cleaner high ends. This humbuckers with a phase reversal, which gets you your jangly twangly, and this is the parallel phase reversal, which also gets you your jangly twangly and more treble, less bass. That gets you more bass, less treble. So yeah, these are the 6 voices. These are the 6 circuits for the 6 voices, and so this is the actual circuit, and that's the same one you saw 2 pages ago, just redrawn a little cleaner. You got your 2 coils on your pickup. Here's the bridge. A is going to be the close one, the cream colored one with the screws. B is the black bobbin. Each bobbin's going to come off to an on-off toggle switch. Then you'll have an on-off phase toggle switch for, I guess, A or B. It doesn't really matter. And then they'll both run into a series parallel switch, which is, one of the diagrams I showed you, and you can look it up online. It's a little bit on the ugly side. And then the output of that, yeah, basically the series parallel circuit is a DP-DT switch that's wired up in a rather fancy, somewhat fancy manner. And basically you've got 4 sets of leads from 2 pickups going in, and you end up with 2 sets of leads coming out as your output, a hot and a ground. So you got 2 hots and 2 grounds going in, and 1 hot and 1 ground coming out. And that goes to, wait, we're putting a volume in here, aren't we? A volume. and then the jack. And that's going to be the circuit right there, I think. Because, see, then I went down, I was like, okay, can we do this with, like, you know, make it easier so that you don't have to, you know, make sure that both coils are turned on, and then I'm in humbucker mode to go humbucker or whatever. I was going to see if I could, like, you know, set it so that you could do A or B or both, kind of with a three-way selector or something. But basically what it boils down to is that a three-way switch, like on a telly, is really only a two-way switch, and then you can get both in parallel. And a five-way switch is really only a three-way switch, and then you can get both in parallel, or all three in the two combinations in parallel. And for this, you're going to need at least a 6-pole double throw switch, just to have like a single switch, one ring to rule them all kind of a thing. So a 6-way double throw is not a very common kind of control for guitar. And if you were to cobble together such a thing from a guitar, the best you could do would be a toggle switch, which would then choose which of the 5-way switches, which of 2 5-way switches you would be using in order to actually choose your voice on your guitar. And some of the positions, only positions 1, 3, and 5 would actually be active, and the rest of them wouldn't really. You might be able to, for some of the parallel circuits and some of the parallel voices, there's like 2 of them out of the 6. You might be able to get away with some of the parallel circuits. So let's say how many parallels we got. I don't know if it can be done, but we got 2 parallel circuits. So let's see if you did a 3-way, that'd give you 2 circuits plus a parallel, so that would cover 3 of the 6 voices. If you did 2 3-ways, that would give you 2 parallels and 4 independent circuits, which would be enough. So you could do it with a selector A or B switch, 2-way switch, and then 2 3-way switches where you'd have your first 3-way switch would be voice 1, voice 2, voice 3, and your second selector switch would be voice 4, voice 5, voice 6. And then you'd have your 2-way switch, which would be voices 1 through 3 and voices 4 through 6. And that's, out of using conventional controls, that's probably about the best you could get. You might be able to get it down to, like, you know, using a 5 and a 3-way and getting voices 1, 2, 3. You might get like 5 voices on the first switch. Actually, you might be able to do that. You might be able to get away with a toggle switch and a 5-way, just that. And what it would be like the toggle switch in one position would be your voices 1 through 5, and then when you hit it to the other direction, it would be voice 6. And when you had it on voices 1 through 5, then you use the 5-way selector switch in order to do voices 1 through 5. Because the 5-way selector is a double pole, so you can switch both the positive and the negative same time to whatever they need to be connected to. And you can, and it's got 2 positions that run the inputs in parallel. So I don't know, you'd have to like look at it and actually figure out if like it could be done, because you need to be running, you know, it might turn out that you got to run jumpers to so many different things simultaneously that that when it's in one position, that's still going to have a jumper going to another position. It's going to end up making something not work. So I don't know if a 5-way would work or not. I didn't try to figure it out. It was looking like it's possible that a 2-way and a 5-way would do it, but I didn't try that. I figured that, you know, you would have to go at least like in worst case, you'd have to go a 2-way and 2 5-ways, assuming that you couldn't use any of the parallel circuits in a 5-way. So, and this is actually not even worst case. Worst case, you've also got to have a third pole in order to worry about the jumpering the two leads together when you're going into series mode. So you might actually have to have one pole for plus from the jack, one pole for minus from the jack, and the third pole that just controls whether the two leads from the one pickup from, you know, like the negative of the first of coil A to the positive of coil B are connected or not. And you would do that with like a 3-way, and then on the third bank, if that was the one that was handling what was connected and not, or for your A to B coil connection, it'd be like, you know, it'd be like hot wired in 5 of the 6 positions or whatever, and it'd be open in the other one, or vice versa kind of thing. So, you know, I guess it's a 5-way switch, so it'd be hot wired in 4 ways and open on the 5th, or that kind of idea. But yeah, in general, it's looking like maybe, like, you know, you have 2 switches to turn the 2 coils on. You turn them both on in order to do your humbucker stuff. You can turn either one off in order to get a single coil. And then you'd have a phase switch, which would get you your phasey sound in any mode that you're using 2 coils in. And then you would have your single parallel switch, which would get you either series parallel, which would get you either series or parallel when you were running 2 coils, and would have no effect when you're running 1 coil. So, and then you've got, where's the rest of the circuit? Yeah, so the on-offs, obviously, you know, you turn on or off whichever coil you want, or both. Phase would only work if they were both on, otherwise would have no effect. Series parallel would only have an effect when they're both on. So, yeah, if they're both on, then this and this will have an effect. And otherwise, they won't. And they'll just pass through, and you don't have to even worry about them then. And so it's very cool in that respect. And then you're just hanging it, and then you're just running it through a volume before you go to the jack. So it's really pretty straightforward. The only thing ugly is, like, alright, well, this is basically just a crisscross wiring of a switch. This one here, the coil split. Yeah, the coil split humbucker's kind of ugly. We're basically going to handle that by having a pair of on-off switches for the coils, because we want to be able to split it either way. And this circuit here gives you a choice between both in series or just one. This coil split humbuckers circuit. This gives you either A split or humbucker, or your 2 choices for the switch. But we want to be able to do A split and humbucker, and we also want to be able to send them both out. We want to be able to do A split, we want to be able to do B split, and we want to be able to turn them both on to do Humbucker, which is series, and we also want to be able to do parallel. So we're going to be doing, this does 2 of the 4 voices that we want to do. It doesn't even, forget about phase. So yeah, this basically does 2 of the 6 total. And if we're taking phase out of the picture, then this only covers 2 of the 4 possibilities. Yeah, this gives you an A split. You can change around the wires and do a B split, but this doesn't give you an A or B or humbucker, and this doesn't give you A or B or both for going humbucker to parallel somewhere downstream, which is really what we want, because we're going to go A or B or both via 2 on-off switches. Granted, 1 single switch, actually, can we turn those 2 on-off switches into a 3-way? I think we can. No, we can't. Can we? Let's see. You might be able to. Would that be better? It's 1 switch versus 2. But is it better to be able to just go, yep, I'm on, or I'm on A, I'm on both, I'm on B. I guess it's a wash kind of thing. Okay, can a 3-way do that? Okay, that's either going to give you A or B or both. But we don't want, for our coil split, we've got 4 going in, and we want 4 going out, not 2 going out, because we want, for A split, we want the 2 A wires, and then we want 2 dead wires, basically, for our output. And then for B split, we want 2 dead wires and then 2 B wires. And then for both, we want A and B positive and negative, all 4 outputs, which a 3-way won't give you, and a 5-way won't give you. They're both only 2 output type switches. So yeah, that won't work. That won't work. 3 and 5-way 2-pole switches are not complex enough, not sophisticated enough, however you want to put it. We need something that's a 4 in, 4 out 3-way. So we need like a 4-pole 3-way switch. You could take 2 2-pole 3-way switches and gang them together and make a 4-pole 3-way switch. So we would take basically 2 Telecaster 3-way selector switches, mount them side by side, tape the 2 knobs together so that they're one, and you can only throw them simultaneously. And that would get us the kind of switch we needed in order to replace our two 2-way switches for A's on, our 2 on-off switches for A and B. Is we would have to replace it with, instead of 2 on-off switches that you have to worry about who's on and who's off, you could do it with a ganged pair of 3-way switches that would give you coil A, coil B, and both, or coil A, both, and coil B, kind of a thing. I think that would work. I suspect. But it might not even work. You really need a 1 in, 4 out kind of a thing, or a 4 in. You need a 4-pole, whatever I said. A 2-pole, no, a 4-pole 2-throw. Yeah. Because you got 4 inputs. the need to switch to 4 different possible outputs. So yeah, that's about the only way to wash it. So okay, enough rambling about electronics. It looks like neither the 3-way nor the 5-way is really going to be suitable to task, and 4 2-way switches is going to be the way to go. And I believe that's the last page of my notes, the conclusion that my little white paper here came to. Yeah, I came up with I could go with a 2-way and 2 5-ways. You could replace, or you can go 4 2-ways. You could replace 4 of the 2-ways with a pair of ganged 3-ways, which would give you like a giant 3-way and 2 2-ways, one for phase and one for series parallel. So then you'd have one switch that did A, B, or both, and then you would have one switch for phase, which only worked when you were in both mode. And then you'd have series or parallel, which would also only work when you were in both mode. So those are the only basic ways that it can be hooked up. And a ganged 3-way sounds more complicated than 2 2-ways. I mean, two 3-ways is more complicated than 2 2-ways, I would think, even if you always throw the 3-ways the same way at the same time. So, whereas with the 2-ways, you don't. You turn them both on. Actually, you get another voice from the 2 2-ways, because you turn both coils on, and you've got either series or parallel, depending, humbucker or parallel, depending on how your other switch is set. But you turn one on or the other one on, and you get A split or B split. But you turn both off, and all of a sudden you've got an on-off switch for your guitar as well. So hey, that's slick. That actually gives you 7 voices, including none. Yeah, I like that. I think I'm going to go that way. 4 2-ways. So, how many minutes are we at? 22 minutes of me rambling about the circuit. Okay, we've got a wiring diagram. We've got our basic, let's see, how to do, we need a series parallel and we need a phase, and I think we can figure out an on-off. So there's our phase right there, and that's just the one that crisscrosses. We're going to do on-offs instead of coil split. And this is our series parallel. Yeah, and we got 2 coils coming in, an A plus and a B plus, and A minus, and there's a B minus around here somewhere. There's B minus. Yeah, so A plus, B plus come in on the A side of the switch, and A minus, B minus coming on the B side of the switch. You jumper across terminal 2 from A to B, and your hot comes off of, it's wired in a somewhat odd manner, and your hots actually come off of terminals 1 as your hot and your ground, as well as being the input for your hot and your ground off of your 2 coils. So, but that's the way it works out. I don't know, if you think about it, it's probably pretty straightforward. The pinouts on one of these switches internally is not that complex. Yeah, really, in order to figure out what's going on, you have to get a combination of a wiring diagram, and then you need the actual internal wiring of the circuit itself, and from that you can get a true schematic of. Sorry about that. Yeah, that's what happens when you're holding the phone by hand. Where'd the true schematics go? There they are. Yeah, that way you can end up with a a schematic like this for these guys. Or 6 little circuits we're going to implement here. So, and yeah, I went through and for each one I made sure that, you know, if this one's turned this way and that one's turned that way, that gets us voice 1, and that gets us voice 2, and that gets us voice 3, and so on down the line. So yeah, this circuit should work, I'm confident. 3 years of getting A's in electronics shop in high school. Sometimes things actually pay off. This guitar electronics and maybe, you know, a little basic, you know, wiring of stereos and hot rods is about the only application I ever found for it. Because I never, you know, I wasn't a double E major, I was an aerospace major, so. Okay, enough rambling. We're at 25 minutes. We've got a wiring diagram. We've got a set of, yeah, we've got wiring diagrams. We've got a parts list for switches and stuff. We're going to need a volume pot. We're going to need 3 DP/DT switches. And I think I probably got all this stuff. And we got a jack, so. With any luck, we're in the house, or we might need a DP/DT switch, and it's about to snow here in Washington, D.C. yet again, so I don't know. I got a buddy with a 4x truck, man. It's a cubic dollars kind of truck. I might be able to call him out. Make a little run to the store to get some DP/DT switches or something. I don't know. We'll see what happens. Until the next one, yeah, go make some sawdust. See y'all later.